Hi everyone, today we are going to learn some new identities. So we've already talked a little bit about the fundamental identities, so that is reciprocal identities such as sine equals 1 over cosecant, Pythagorean identities such as sine squared plus cosine squared equals 1. We have the quotient identity, which is tangent is sine over cosine, and then we had some even odds. So hopefully by this point you're starting to get those down more since we've been practicing with them quite a bit. But today we're going to learn some new identities. So these are called the sum and difference formulas for sine, cosine, and tangent. And so what we have going on here is we are adding or subtracting two different angles. So in these formulas, sine of alpha plus beta, those are two different angles, and it equals these different long formulas that you see. So I would say take a moment to pause the video and copy all of these down, and then we can talk a little bit more about it. All right, so first of all, why do we need these identities? They can help us find exact values of angles that are not on the unit circle. So if we can break an angle down into two angles that are on the unit circle, we can use those identities to help us. One thing I do want to note here is that we have to use these identities. So for example, if I'm trying to do sine of 75 degrees, that is not going to be the same as sine of, let's say, 30 degrees plus sine of 45 degrees. And you can kind of verify that in your calculator by typing in sine 75, make sure you're in degree mode, and seeing what that decimal is, and then doing sine 30 plus sine 45, and you'll see that they're different decimals. So that's one thing to watch out for, is that we have to use these identities if we're trying to do a sine of the sum or difference of two angles. Okay, so looking at this first one, I'm trying to match which sum or difference formula this is. So I see cosine, cosine, and a plus, then I see sine, sine. So looking at my different identities, that matches this form right here, where 70 is my alpha and 40 is my beta. So I'm trying to use cosine of alpha minus beta. So plugging in those values, we get cosine of 70 minus 40, and that is cosine of 30, which is on my unit circle. That is root 3 over 2. Okay, so this is kind of using the identity working backwards. Now on this next problem, we're going to go the other way with it. So we're trying to find the exact value of sine of 5 pi over 12. Now 5 pi over 12 is not on our unit circle, but we can break it apart into two angles that are on the unit circle and then use our identity. So sine of 5 pi over 12, I'm thinking 5 pi over 12 can split up into 2 pi over 3 and 3 pi, 2 pi over 12 and 3 pi over 12. Sine 2 pi over 12 plus 3 pi over 12. So now that is equivalent to 5 pi over 12. And now I'm just going to reduce these fractions. So 2 pi over 12 reduces to pi over 6, and 3 pi over 12 reduces to pi over 4. And those two angles are on our unit circle, so we can use these angles for our exact values. So I'm going to say that pi over 6 is our alpha, and pi over 4 is our beta. Now looking back up at our formulas, we want to use this sine alpha plus beta formula. All right, so I'm going to come back down here. So that is going to equal sine pi over 6 cosine pi over 4 plus cosine pi over 6 sine pi over 4. All right, and now we can evaluate these on our unit circle. So Sine of pi over 6 is 1/2. Cosine pi over 4 is root 2 over 2. Cosine pi over 6 is root 3 over 2. And sine pi over 4 is root 2 over 2. Okay, so simplifying those fractions, multiplying, we get root 2 over 4 plus root 3 times root 2 is root 6 over 4. And the final simplified way we want to write it is just all as one fraction with a common denominator. Okay, so this is the exact value of sine of 5 pi over 12. Now you could check it. So on your calculator, make sure it's in radian mode because we're using radian. You can type in sine of 5 pi over 12 and then type in root 2 plus root 6 all divided by 4, and you should get the same decimal. All right, one more. So looking at this one, I'm trying to match which tangent identity this is going with. And so checking my identities, this one matches up with tangent of alpha plus beta, where my alpha is pi over 5 and my beta is pi over 4. So if we plug those in, we get tangent pi over 5 plus 4 pi over 5. Well, I think I said something weird earlier about beta. It's 4 pi over 5. And 1 pi over 5 plus 4 pi over 5 is 5 pi over 5, which is just 1 pi. All right, so tangent of pi. So just a little refresher. Pi is right there on our unit circle. The coordinates is -1, 0. And so remember, tangent is y over x. So if we do our y over x at that location, we get 0. Okay, so that's the answer to that one. Thanks so much for watching.